And now let's see how we can create an app on precisionFDA. In the App section of the website, I can click Create App to create a new application. In this example, let me create an app for calculating VCF statistics. I can call my app VCF Statistics and give it a nice title such as VCF Statistics Generator. Once I provide a name and a title, I will be presented with 4 different tabs to specify exactly the details of my application. In this first tab, we are discussing the input-output specification of the application. Specifically, what does the app take as input and what will the app produce? In my example, I want to take a VCF file and return back to the user some statistics about it. So my input will be a single file and my output will be also a file. Now for the input file, I need to provide a nickname. So let's call it variance, since this is going to be the input file, and a better label for the user. So let me say variance VCF. I can also put some help text to make it easier for people to understand what it is that they need to give us. So a VCF file containing variance whose statistics will be calculated. Now the output file will contain some statistics. I'm going to nickname it stats and the label will be statistics file. And the help text will be perhaps a text file containing statistics as calculated by BCF tools. And I am done. I just need to remember I have a single input nicknamed variance and a single output nicknamed stats. I can now move on to the VM environment tab. This tab allows me to understand how the app will work in terms of the kind of computer configuration will be used on the cloud. I can choose whether I want internet access. In this case, there is no need for my app to use the internet. And what is the baseline configuration for the computer? If I click here where I see a full list, you'll note there are different options depending on number of CPU cores, memory, and hard disk. The default being baseline 8, containing 8 cores, 15 gigs of memory, and 160 gigs of solid-state hard disk space. I am okay with the default, so I can move on to choosing assets and Ubuntu packages. So by default, my app will run on an Ubuntu 14 vanilla installation, but I can add additional packages by specifying them in this box, or I can add additional bioinformatics software or other reference information and data files by choosing them from the asset library that the community has built on precisionFDA. If I click on Select Assets, I am presented with a list of all the assets that have been publicly made available by the precisionFDA team or other participants. I can tick any of them and include them on my Ubuntu virtual machine on the cloud. Or if I'm not sure which one I want, but I'm looking for a particular executable or something else, I can search it here. So in this case, I'm looking for BCF tools, which is a package that can calculate the statistics on a VCF. And I'll notice there are 2 different versions, 1.2 or 1.3. Let's say I choose BCF Tools 1.3. You'll notice where it says Archive Contents, it actually puts user bin BCF Tools to the Ubuntu VM. So by ticking this BCF Tools asset, I will have access to the BCF Tools executable. Each of these assets contains also some example usage, links to where the asset's source files are, as well as some small documentation. Now that I've updated my selection, my VM will contain BCF Tools 1.3. Next, I can start writing the script that will power my application. So far, we know that I'll be getting a variance file and I will be working on an Ubuntu virtual machine containing the BCF tools executable, and I need to create a statistics file. This is going to be done using the bash script here, the shell script, where I just need to invoke BCF tools, the stats operation of BCF tools, and I'm going to operate on the input file. Now, if I click Learn More about the app script, I will actually go to a documentation describing how I can write my script. And in particular, as the documentation shows, if I have defined any input with a nickname, such as field, then all these variables are automatically defined. Field path is actually the variable containing the full path of that input file on the local hard drive. Therefore, since I named it variance, I can just say variance path. And this is just going to be whatever the file is named by the user when they give it to me as it lies on the local hard drive of the VM. So I'm calculating the statistics, and then this is going to create a file. So I need to redirect the output somewhere. Let me call it output.stats.txt. This is practically all that my app needs to do, except now we need to associate this file with the statistics output that we've defined. And this is done with a little utility called emit. Emit takes two arguments. The first argument is the name of the output, and if I go back to the spec, I named this output stats, so I need to emit stats. And the second argument is what file will actually be emitted and associated with this output. And since I've created something called output.stats.txt, that's all I need in order to associate this file with the statistics output. Finally, I can click on the README tab and say a few words about my application using Markdown syntax. So I can add a header saying VCF statistics generator, and then add a few words about what my app actually does. When I'm ready to create the app, I click on the Create button. Once I create the app, you will notice that I am taken to a page showing the specification of the app, and I can actually run it by clicking Run. You'll notice also that the revision of the app is number 1. This is the first ever edit I've ever made to the app, but I can make further edits by clicking the Edit button, changing something like the input spec, the VM, or the script, and then saving it into a new revision. If I click Run to run this app, I will be presented exactly with the inputs that I have asked to be provided, in this particular case, the variance VCF file. So if I click Select File and choose one of my VCF files, and then name this invocation, I am then ready to run this app. Now, when I click Run App, it actually schedules the execution of this app on the cloud. So now an Ubuntu VM will be created with the BCF tools asset that I ticked and with this VCF file that I chose as input on the hard drive. And then the script is going to run invoking BCF tools stats, generating the output file, and then outputting that as the stats. Depending on the cloud availability, my app may take up to 5 or 15 minutes to be launched, and then depending on what my script does, it may take anything from a few seconds to several hours to complete. In this particular case, you'll notice that it completed only in 17 seconds and created this statistics file. I can click on the stats file and then click Open to open it directly in my web browser. and I'll see exactly what BCF Tools stats output for my VCF file. But I can also go back and take a look at the logs. When I click View Log, I can actually see exactly what got executed. So you'll notice that it fetched the asset, it downloaded the small demo file that I gave it as input, and then it executed BCF Tools stats, and then emitted back the result. Lastly, if I want to keep this app around but make a slight variation in a completely new app, I can click on the Fork button. By clicking Fork, I am presented with the same user interface, except any changes I make can be saved as a completely new app. Finally, if I'd like to publish this app and make it available to the community, I can just click the Publish button. Thank you.